Hello and welcome back to the show. My name's Relevant. This is Do All the Things. On today's episode, continuing the setup and fine-tuning of my 12-volt solar charging infrastructure, I am going to take my inverter and I'm going to modify it into its final form. So if you've been following the comedy, you know that I did this solar system install for the sole purpose of charging all my batteries. So pretty much anything in my inventory that runs off batteries now is free power, minus the cost of the batteries themselves, because you know those do wear out over time. But you know, one of the key features of this system is the inverter. Now, many of my chargers run direct DC right off the battery, but some chargers, like, you know, my Nikon camera charger, this camera right here, it is still plug-in. And I don't know that Nikon makes a DC charger for this battery. And then, of course, there's my AA charger. I want to get a AA charger that runs off direct DC, like an Opus smart charger kind of thing. That would be handy. But for now, I run them off this guy. And this is a Blue Hive 120 watt, more than good enough. It's performed quite well. So, modify it. What do you mean by modify it? Well, it looks awfully derpy right now when it's set up. Right now when I'm using on this thing, we got a situation where like, it plugs in kind of like that, and then plug that in, and yeah, that looks derpy. That's no bueno. So, I want it to be nicer than that. Now, I've already been probing in on this thing, so I kind of have a good idea of what to do. Now, I don't know what this says about their right to repair, but there's no trickery getting this thing taken apart. We just have 4 screws, bud. 4 normal Phillips screws. And then, oh, where is it? Where is it? There is some sort of pop facility, I guess. I forgot to do the disclaimer. So this is an inverter. It puts out 120 main style voltage. If you do anything like what I'm doing right now and you do it wrong, this can get angry. And you know, if your house burns down, well, you're gonna have trouble with your insurance company because you've voided your ETL listing. So that said, this video is for entertainment purposes only. Now, moving right along, we open her up. Ground prong is just this little thing. Okay, there's our 2 mains output prongs. Here's our 12-volt connector. And then once we get her loose, she slides out. And boom, there's our circuit, bud. Oh yeah, it's just a fancy switch mode boost. And it has a fan. Oh, whoa, there was some power in there. Oh. Yeah. Now you see why you don't do this at home. Okay, let's handle this a little bit more carefully. As I was saying, we have a fan and we have these guys right here. I think they're the power MOSFETs that drive this guy. So what happens is 12 volts comes in and then a little bit of buffering. I'm guessing that's what that is. These MOSFETs will switch on and off, on and off, on and off, so that we get inductive jolts of power going to this transformer, and then this transformer starts doing its job. It's gonna be a step up, 12 volts in, obviously, or something to that effect. And then output, it's gonna drive, you know, something close to 120 volts. These are probably the output MOSFETs that are going to actually switch it and vary it into the 60 hertz AC sine wave. So yeah, that's going to get rectified, and then these guys are going to turn it into an AC sine wave. So that's the nuts and bolts of it. This guy has built-on USB, and it's this module, which I confirmed is just connected to battery power, right from the battery to there. So this is just a standalone USB module. We could remove that and repurpose it, use it as a USB charger elsewhere if we wanted to. Now, the only thing I don't like about this guy is it can get loud, right? You got this little fan, it starts spinning to keep this guy cool with this chintzy little heatsink. So far, it's not so loud that it irritates me. So here's the plan. We just have these wires going into here, and then there's our 12 volt. We're gonna flag these. This side's positive. You know, I'm not gonna modify in the output section, but I'm gonna modify in the input section, the low voltage side. So I don't feel like that's a big deal asking a lot of it. But the plan here is that I'm going to remove these wires for the power input. And bam. So we need to clean up these holes and get some new wires in there. Is it gonna fit my vise? Oh yeah, my mini vise is just big enough, bud. Hey, let's get the solder sticker. Solder second. So we get 1 hole, I do believe. Yeah, it might not be able to suck through because all the other crap on the other side. That or there's just a lot of solder here. Oh, there's a nice gaping hole. All right. Aha, frick, it's hot. Geez, I'm burning myself and electrocuting myself today. You guys are getting quite the value entertainment. All right. Just make it so that we can get at those holes, except we kind of violated the shmoo that's holding this cap, but This isn't going into a car, so I'm not expecting that to come loose anytime soon. So now I want to solder new wires on there. And again, I'm going to repurpose the 16 gauge that came with the lighter socket I installed. So no particular color coding, just a bunch of red wire. And I'm going to use an old trick there. When I have a continuous piece of wire and I don't know how long I'm going to need, basically what I do is I get the end of both ends of the wire, right? So that's a loop. This is just the both ends. And I'm going to connect this on in one continuous loop. So you get the wire through the hole, give it a little foldy over. This is a nice 16 gauge. I'm replacing, the original wire was 18. 16 is gonna be able to handle no problem with the lengths that I'm doing, right? So I got one end of the wire, and then this end of the wire. That should be on there good now. As you can imagine, it's gonna make it real super easy to keep track of which side's positive and which side's negative. Not. So what we will do, gotta find which side's negative, and I'm gonna draw a black mark on it. Reasonable distance outside of the shell. Now let's see how this thing goes back together. We need to flip this over, and then it slides back into its spot here. Pop the fan back in. That LED is loosey-goosey until we put it through the correct hole. Gotta make sure that stays spooled. And then this is just gonna emanate out the back. We got these side panels, fan grills. Poke the LED through its little hole, and another fan grill piece. Oh, the fan grill pieces, I think they snap on after you put it together. So line everything up and have it not fit right because something's out of alignment. There we go, there we go. Now these side pieces should just snap back on. Yeah, that kind of holds it together. And yeah, we just have this area kind of hanging out there. I'm gonna put the screws back in. Okay, so yeah, sexy. No strain relief on this. Fortunately, I don't think we really need it. Not the way I'm building this, so we can get away without it. You know what? Yeah, that's the heatsink. If we leave this open, it'll be able to ventilate easier. Maybe it'll run cooler and quieter because I can hear the fan does have some form of RPM control. It doesn't just run on. It doesn't kick on till things get warmed up. So for mounting this to the actual backboard, as I mentioned, it has a fan and I want to hard mount it. But the problem is if you just bolt it or strap it to the wood board, the vibrations from the fan get resonated into that board. Sounds quite irritating. So I'm going to be using some hackery. I feel like I want to have this side face out so we can see the specifications. And so here's what I'm thinking. You know when you build a computer, or they don't have them anymore, but they used to have the 5 1/4 bays, and the unused bay or the spare bay would have like these metal covers, and then like you don't throw out the metal covers wondering, oh, it's gonna come in handy. Hey, it's gonna come in handy. So then I got a piece of foam, and I have my hot glue gun, which I hopefully is warmed up by now. I'm just gonna put something underneath so it doesn't accidentally stick to my workbench. And yeah, maybe like bum 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 bum. Make sure you use the sound effects for extra authentic gluing pleasure. Oh, it looks like I can run a bead along the edge here. Give that a moment to cool down. It looks like this paint chip is permanently part of it now. It just had a splash of color. So once that's glued, the next part of the plan is to just glue that on there, right? And we want to get the leverage as such. We're just gonna glue it on there, bud. All right. Shmoosh, 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 shmoosh. Oh, I'm going too fast. The glue can't get hot enough. Remember the sound effects. Helps the glue bond better. And I don't think this is gonna be a good idea already. Let's see. Oh, you know what? I think it'll be okay. It'll be a little cattywampus, but it'll be okay. It's probably gonna fall off at some point. And I didn't get it centered because I was going too fast. I think I should be able to remove this now. All right, let's go strap her to the board, bud. So the idea here now is somewhere up here, just like right about, oh, we can have this come around the back. Let's get that as high as possible. Let's pre-support this wire to simulate it not putting weight on the thing. Oh yeah, that's gonna look awesome, bud. That's gonna look like a whole lot of suck. In fact, this isn't gonna work because once I plug something into it, it's gonna touch the board and the vibration's gonna go through the plug. Unless I stick foam behind the plug itself. Well, that is our target mounting position, so let's blow a couple screws in there and just make it so. The next order of business is to get this wired into the box. And that's what this silly blue thing that I installed is all about. just push it through the hole. Now here's where we really gotta start using your pay attentions because they're both red, right? So the black wire, which one's the black wire? This one's the black wire. So that's the black wire. I gotta get that onto the ground strip. Like right about there like that, bud. Okay, gonna mark that with my fingernail. You see, no wire waste this way. More crimping. Yay. Get that onto a ground strip position. This guy, well, we're gonna put it on the unused channel too. So onto that connector right there is gonna be our wire. So we want this wire to come, I guess, relatively in and around, out of the way and wrap around kind of like that. It's a little bit longer, but it's gonna allow for some cable management, which is important to us PC enthusiasts. All right, let's get her crimped up there, bud. And snip on. Haha. So now, assuming I didn't get the polarity wrong, this should work. There's no light. Oh, it's because there's no fuse. It's too bad they're big fuses because this thing came with a mini fuse I could have used in here. So again, it's calling for an 8 amp fuse. The device itself says input 14.2 volts, 7.8 amps. This mounting method's not gonna work. Oh. Let's continue digging for our fuse. I don't keep a lot of 8 amp fuses around. I found an 8 amp fuse. I have exactly one of them. Wow, isn't that convenient? All right, and if it blows instantly because I did this wrong, then I'm not gonna have an 8 amp fuse anymore. But it did not. Except I gotta remount it, sir. This failed miserably because it was pull apart foam. Derp. So fortunately for us, we could just, disconnect on it. Ugh. How easy it is to get out past this grommet de fromage. Oh, the grommet just pops out, so we'll just take it with us. Okay, so this is a horrible failure. Oh, hey. Fortunately, the glue doesn't stick that well to this metal, but it probably sticks great to this plastic. Oh boy, we now have a hump of shmoo here. I shall not be defeated by chunk of shmoo. Ah, that got hot fast. Now it's like part of my pores. So yeah, obviously one of the great things about hot glue is you can remove it with heat, right? Okay, so take two. How are we gonna mount this? How about we get a little less ambitious and use a harder foam? Yeah, that sounds like a plan to me. Shmoo goo, take two. We don't even need as much glue now that we know how well it sticks to this box. Oh, okay, wait for it to dry, bud. Oh, the hot glue melted the foam. I did not see that coming. This foam does not have a high enough temperature threshold to be hot glued to. Who knew this was gonna be such an educational experience? Okay, let's try splitting the difference this way. This is a firmer, harder foam that does not pull apart. It's one solid mass. Let's get some fresh glue on there. And because it's such a mess, what we're gonna do, let's heat it up and wait for it to cool. Wow, it's taking time to cool because I heated it up so much and the foam is like insulating it. I'm not gonna lie, hilarity has ensued a little bit more than I anticipated for this project. Yeah, it's definitely gonna hold it nicer. So based on my inference of the center of gravity, I'm gonna put this bar up higher so that it can lean against here. We'll just use our good old friend glue again. We can sneak some under the flexibleness that is the foam and maybe flatten it out a bit. Glue's not hard yet. Gonna reinforce it in and around the corners. I probably should have done some surface prep to this metal. Just making a little weld joint over top here where it sticks to the foam and kind of hangs off the top. We're getting super artistic here, bud. That should do. Just let it cool down a bit. Ugh, just when you thought it was cool. No. Come to my attention that putting the screws in has made some of these sections not so flat anymore. Let's reflatten on them. Hammers are handy. Ugh, stop poking at it. So the next thing on the chopping block while we're waiting for this glue to dry is what I'm actually gonna plug stuff into. I'm not gonna plug it in directly into that thing because it's inconvenient. This is how I used to charge my batteries. So what we have here is a kind of homemade extension cord type dealie. This is 16 gauge heater cord, put an end on it, and then one of these. I don't know why these exist because I can't think of many applications in which code would allow these, but it made a handy extension cord. And so it's got the rubber feet and it just kind of sits all nice on the table. And then, I just plug my chargers into it like that. And that's been on that shelf for years now, and that's how I've charged it. You see, I can run 2 chargers. It's like a little power bar for that thing. Nothing too crazy. 120 watts, you run a couple chargers that are like what? How many wattages each, 16 to 20 watts. This doesn't have a wattage, but I can tell by the amperage, it's not lots. So the idea is, this is just gonna go up into the thing. I'm just gonna cut this line down and put the end on it there. But that implies measuring. Let's go throw it up. All right, so what I want is for this thing to sit right about here and then just snip into there. Maybe back a little more, maybe sideways. Sky's the limit, bud. Maybe I want to slack on it so that I can move it where I want. You know what? That's probably a safer bet. So we'll give ourselves, you know, a little bit of wiggle room. Snip. Now we just suffer the annoying process of getting one of these installed. These particular plugins aren't the best design. They looked nice, but they're kind of super annoying to get wrapped around. I remember now why I don't like these, but then these prongs slip right out. All right, let's get this on the new line. Do they give you some form of strip gauge on this? This is robust wire, like it's not bad wire by any means used for this application. So if I do this the way I think we're supposed to do it, and we just like raw dog stick stranded wire under there, I think that'll do. Just like that, bud. Looks like we pinch insulation through this hole and then it gets held in by that midpoint. I guess it works. Yeah, okay. Some of these strands are poking out, but granted, this is for a not very load-bearing circuit, so it should be within spec. All right, now I just have a cool whip, which to plug our chargers into. Let's go try it. All right, so the idea is plug it in. Yeah, it holds decently well. Just what to do with all this slack, tuck it under here. Good enough. All right, now we turn this on. This system should kick on. And now we can charge our battery. It's working. Yeah, okay, this is good. Now we have a much nicer 120 volt facility, and that thing looks like it's gonna stay there nice now. It's just a question of how much noise is it gonna make when the fan starts spinning. And it can exhaust out the top now, which is nice. And I don't think I'll get electrocuted if you stick your finger in there. Not that you're gonna be sticking your finger in there. There's no reason to, bud. Don't stick your finger in there, bud. What are you thinking? Come on now. Now, the next item on the chopping block is I want to wire up my doorbell. As you know, it runs off battery power. So why run it off a separate battery when I have that one right there? And it's actually closer than where the other battery is located. Now, that might not seem too interesting, but it kind of sets the stage on exactly how I'm going to facilitate external power feeds coming out of this distro. So at some point in human history, I was at one of those hard stores and I found this thing here. And what is this? This is 18 gauge Nomex type wire. You know, like the wire you wire your house with, but 18 gauge. And there's no real provisions in code to actually use 18 gauge wire. So I wasn't exactly sure what this was for. They got some similar stuff in brown that's used for like, you know, your actual doorbell and wiring up furnace controls and whatnot. But this one in red, well, that's cute. I like this one in red. It has DC color coding on it, but either way, it's gonna be perfect for this application. 18 gauge is good for, well, I don't have the ampacity chart accessible right now, but you know, easily 3 amps, probably more than that depending on the distance. And I do believe this is 90C rated. It's not really clear. Oh, it might be 105C rated. But 300 volt, 18 gauge, 2 conductor, DC wiring, red and black. So I think this is gonna work nicely for some of what I'm trying to do here. Meanwhile, it's just kind of raw wire. Needs some sort of protection, some sort of, you know, dress it up as it goes in the general up direction. So I just got some of this stuff. This is that corrugated loom or whatever you want to call it. That's for protecting wires in automotive. Now this wouldn't also be to code for actual 120 volt, but for low voltage DC applications like this, it's going to be fine. And it seems like it fits reasonably well in 1/2 inch connectors, which is why I put that 90 on the box when I reworked it, because that's where this is going to feed in and out. So I think one of the first things I need to do is fit this up, get the proper length, get it mounted up there, and then yeah, we can run wires through it. So that connector that I mentioned is hiding up in here. We can barely see it, or at least you can barely see it. I can see it just fine. And I can kind of just slot that. The 90 facilitates this even better than a straight connector does. And it's some old used 90 that quite frankly wasn't good enough for real wire. So a little bit of trickery getting it on there because I made it so freaking tight. In retrospect, the top of this might not have been the best place because there's very little clearance to work. Come on, just slip in there. So, if we can sneak the camera up in here, yeah, it's gonna look generally like that when we're done. I think that'll do nicely. So, we generally need to get this fed upwards into the ceiling area so that wires can kind of get up into here. And I think we're pretty much just gonna follow the path of this existing wire that goes to the solar system. Yeah, something like that. Yeah, it's a little bit coily. Okay, so that's the existing solar junction. We'll just kind of follow this. I guess this'll work. And then I guess I'll just strap it along with this line. That's gonna make it tricky to add more wires in, and I do have at least one other feed going through here. At least, bud. We'll get it ready to do that, but not actually do it. I think the next step's gonna be to run the actual wire. So like the solar system's generally right here. We just have to get that wire, and then the doorbell circuit is right there. As you can see, easy enough run. Do you blame me for wanting to do this? Ah, sweet, it just fits on my Sears Special spool holder. I don't know what this thing was for, like wrapping paper or something, but it is handy for pulling wires. All right, so doorbell be here. Ceiling tiles be here. This is the part. Oh yeah, I need safety glasses for this. Like, it doesn't freaking matter. Those little particles, they go right through plastic. Don't ask me how. It's some sort of law of physics that I'm not aware of because I'm not a mathematician, but hey, it's better than nothing, I think. Let's try this again, sir. Oh, goes over here, it goes this way, then it's gonna go over here, and then there's not really any holes in that stud. We just slap it to the bottom. I gotta find a little hole up here that's not too busy, even though debatably, I don't know if this low voltage line's supposed to go knocking boots at these high voltage lines. At least one of them's low voltage coming from the solar panel. I think it's probably one of these fresher looking ones. Oh, I think there's just enough room to sneak this little guy through. Oh yeah, bud, no problem. We're rolling quickly here now. Oh, what did I tell you? I just felt a particle hit my eye. You little... Okay, gotta find a path here. Hey, there's just enough room through this little wire hook. I guess we'll just shoot this through over to there, just like that. We'll just zip tie this to the existing solar line. Keep all the low voltage stuff together. Except we're a bit taut now, bud. Okay, so around like this is the general path we're gonna take, and then down and through, and need more slack. We should be able to make that work now. Close anyway, close. We're gonna need slack in the box, so give me a little bit more. Slack in the box, yeah. All right, so let's get this mocked up into the loom here, and then we can get it installed in the box. And then this end will be terminated, and then we should be able to just button it up the rest of the way. So, we just wanna get this down through this hole here. And then this should be enough slack to go everywhere we want in here. Now, I guess we can get this cover on. It's gonna be tricky because I can't get a screw in there. Now, I guess we'll just manipulate on that screw sideways here. This is going quicker and easier than I'm expecting it to. Oh well, it's in there now. We don't need the world's most clamping force. Just need to keep it in there, right? I'll just pop this up into the loom. Oh, it doesn't go in as smoothly as I expected. Oh, it's because it's not broken in yet. So we're loomed up to here, which is about where I'm gonna terminate it, right? Though I still need to slack on this, so I guess I need more yet. Now it's when it's gonna start to get tricky. We got like crossover points here. I think we can solve that. Let's just do one of these. Oh yeah, bud, crisis averted. I'm gonna use a bunch of scrap twist ties to kind of button this together temporarily. That should allow me to lay the cable in such a way that when I'm ready to add to it, because it's not complete yet, I'm gonna be able to. Just up in here, how do we wanna, kind of feel like I need to strap this down, maybe right about there, just to say. And that strap's gonna be easy enough to pull off. Okay, let's start buttoning this together. Oh, this is just a touch too short, bud. Oh, I think it's gonna be just good enough though. Okay, okay. We're gonna need longer ones though. This is a good place to use up the ugly twist ties. It's like you get them and you don't want to throw them out. They're not nice enough to use in a computer build or anything like that. This is actually working quite nicely, buds. Oh, looks like we gotta stuff a bit more of this. Caution, overhead wires. At some point I need to cut on this so there's room for the wires to go through pretty like. Okay, I think we got this sorted out. I know now about where I want to snip on this loom. Right about, yeah. Careful not to cut your wire. Also should probably be using a better scissor. All right. Oh, where I put that isn't the best place to get a screwdriver in to strap this down. Let's see. Oh yeah, no way, no how. Wish I had thought of that before. Well, there's no rule saying I have to strap it up top. I could kind of, well, maybe if I come down a bit here, I could just sneak the clamp in there. Let us try. Okay, it'll do. So she comes out of the box, straps on right about there, and then zip, zip, zip. Oh, she's hiding from that point, bud. Over here by the internets, it comes up into the general ceiling area. Strap there, cut, and there's our wire. So now we can go ahead and officiate that wire into the doorbell circuit, which doth involve cable management from this point, where I will zip tie it to the solar line that passes through. We're not expecting this to move after, and it sucks that it's crossing over this guy. You little... I made a routing error. It's not the end of the world, but there's no way to correct that without disconnecting the line at some point. Oof. You know what? I'll put the straps on loose so we can get the lay of the cable. And once I snip it on the doorbell end, I can pull it back, refeed it through. All right, we gotta slack through here. And it has to start heading this way. I'm gonna strap it right about up in here. Oh, I feel another routing error here. Okay. And then there is a hole there. All right. I think it's safe to say we could chop it right about here. You know, you route a wire a specific way, so it's gonna be perfect. Then you make one little mistake and you gotta reroute the whole damn thing. That's fine. That's just fine. On snap. All right, let's pull it all back through now. You wanna be careful, because solid copper wire can work hardened, so you don't wanna have to do something like this too often. This is what I'm talking about. This is the initial routing error. I just want it to follow this line, but it's wrapped around this. That's a high voltage line. That's just the light for the shed, the three-way switch if you watch Project Shed. So we gotta pull it all back through just to do this. Yay. All right, let's start zipping her. And how about a little zip, zip, yeah. Zip, zip, yeah. Then somewhere around here, gonna be a little zip, zip, yeah. Oh yeah, didn't I have a zip, zip here? Yeah, there's a zip, zip up in here. Aha. And there's already a little loop to use here. And we have made it to the doorbell. So we can put this back into place. Come on now, come on, you can do it. It's raining. Whew. Now we can get that doorbell wired up. But first we will dewire the old doorbell. Oh, look at that fuse. I had no spare fuses. There's no excuse for that. I'm sorry you had to see that. Let's just disconnect power from the doorbell. Gonna have to label that as does nothing, but it does go somewhere. And there is the doorbell circuit in glorious. Looks like crap potato vision because there's no light. And then there's our power. Well, let's get that. Onto that. It's not gonna work, bud. Oh, look at that nice shiny copper wire. All right, that's hooked up. Now we just have to get power to this line. And that, as you can imagine, entails more fidgety-digity in this general area. So, big line comes down here. Gotta give this a generous stripping. What if I maybe I could, let's see here. Oh, okay. Just have to massage it out now. All right, so ground and power, bend it off over here. Ground's got to come down to this luggy situation. So we'll just kind of tuck this down here. Positive, I'll use one of these terminals. We'll come back around here like this. Oh, look at that, just enough room. We will splice on a spade here. That's ready. We'll just give it a general routing. Snip that on there. I use these forks for the ground bus, but I don't have any forks the correct gauge. But these lugs, well, we can wrap a wire around them. We'll put it on this empty lug here so that the wire wrapping method doesn't interfere with any of these other guys. I'm not gonna go run out and buy a brand new pack of forks for this one wire, though I am gonna have these more of these 18 gauges coming in here. So I'm likely gonna get it at some point, and I'll correct it then. Kick it old school, yeah, secure that down. Now for fusing, another 3 amp fuse in this position. Turn the power on. Let us go press the button and see what happens. So right here, we have a test button. It works! Our doorbell is now running off solar power. Small victory. And now we have a good idea how we're gonna be running power lines out of that box, or at least you do. So, I think we're done for today. If you like this, stay tuned. I have a more ambitious power run to do where I'm gonna put USB in my bedroom, and then I have to sort out chargers. So, stay tuned and find out. The lady just showed up. I better help her load the groceries.